I visit a lot of conferences and meetups, like this one. And sometimes as a speaker, most of the time as an attendee. And I think they're really useful, and there are always speakers that inspire you, who think outside the box, introduce new concepts, and come up with new solutions, who make you want to run to your computer and try out amazing new things. And these inspirational talks are absolutely fantastic. And they use these epic background photos with insightful quotes, and exquisite typography. But this isn't that kind of talk. That's not me. I do browser compatibility testing. I'm the grumpy old man shouting down from the balcony, your shit doesn't work. My name is Niels Leenheer. I run the third largest open device lab in Europe, and we have almost 200 different devices, and I created the HTML5 test website. And that's a site for testing web standards. Basically, you visit the site with a browser, and it runs a whole bunch of feature detection tests. And you get points for every test that passes. And the score is, the points are total up, and you get a score, and it's between 0 and 555. Why 555? 555, it's HTML5 test. Anyway, before my talk, I want to show you the current state of desktop browsers on HTML5 test. And the top browser is Chrome. Firefox is the runner-up, and Safari used to be third, and IE last, but that has changed. Yeah. But the score is not the most interesting part to me. It's just a number, and who is first or second, it's not important at all. All browsers listed here are perfectly good browsers for today's web. And the actual results are much more interesting to me. But the score is not meaningless. Scores are very interesting to show trends like this. And we can see Microsoft has really done a good job since Internet Explorer 6. Anyway, my talk is about weird browsers. And what are weird browsers? Well, browsers and devices that do not adhere to current expectations. And I have an example from the past. We have regular computers with a mouse or trackpad, and we have phones and tablets with touchscreens. We have mouse events, we have touch events. And because we want to make our buttons react without a 300 millisecond delay, we want to use touch events. By the way, thank you, Apple. But if we just detect touch events and listen for touch events and otherwise listen for mouse events, I think we're going to have a problem, because this is a really big assumption. What happens if you connect a mouse to a tablet? Well, suddenly that code wasn't a good idea anymore. And the same thing with a laptop with a touchscreen. So, weird browsers. Are there actually any weird browsers left? Mobile is the new normal. Everybody builds responsive websites. Where can we find these weird browsers? Well, I have some candidates. Game consoles. Portable game consoles. Smart TVs maybe. Perhaps e-readers. They all have browsers. Smartwatches. Photo cameras. Even cars have browsers. And this is a photograph of the Tesla S, which has a big touchscreen in its dashboard that runs a browser. And unfortunately, I don't have a Tesla S in my device lab. By the way, is there anybody from Tesla here? I'd like to talk to you. But I think we have a lot of candidates. Well, what do they have in common? Well, the situation is comparable to mobile before the iPhone and Android. Everybody is trying to figure out and sometimes failing spectacularly. And we can't look at everything tonight. And like I said, I don't have a Tesla in the test lab, so I've made a selection. And let's start with smart TVs, set-top boxes, and consoles. And I've grouped them together because they're basically all the same thing. They're big screen browsers. And immediately we have a problem because I have just one smart TV at home. And maybe some of you have none, or maybe one. But I doubt you have two or more. And there are very different browsers on these smart TVs. So where can you go to test your website on smart TVs? MediaMarkt. I went to my local MediaMarkt and asked them to do some browser testing, and then they looked at me funny, and after some convincing they walked to a big drawer, handed me 5 remotes and said, here you go. They still thought I was crazy, but they wanted to sell TVs, so that's fine. One of the things that I immediately noticed was that browsers on televisions are actually pretty good. Sorry. And the last generation is actually based on the same rendering engines and operating systems as your mobile phones, like Android or Firefox OS, well, Tizen, WebOS, which are not that well known, but they're actually pretty good operating systems and rendering engines. The scores in HTML5 tests are not that bad either. They're not as good as the desktop browsers, but it could be worse. If you compare these results to, for example, game consoles, you can see a clear difference because, well, game consoles have a slower turnaround. So the game consoles we now use are already a few years old, and the last generation is already 5 or 6 years old maybe. So you can see the scores are a little bit lower, and there's a clear separation between the current generation and the last generation. One other thing I immediately noticed was that smart TVs have much lower memory and slower CPUs. It's better than before, but it's still not optimal. So, what are the big differences? First of all, control. The biggest difference is at the same time one of the biggest problems. Because how do you navigate without a mouse or a touchscreen? Well, you have D-pads, remotes with D-pads. It's basically arrow keys and you move from link to link by pressing the arrow keys. It's a bit like tab navigation. And it works basically the same. You move to link, from link to link, and one of the things you have to make sure is that all your links are actually focusable. You could use, for example, a div with an on-click handler for custom components, but that's not going to work if you can't navigate to it. So you have to use tab index. But it's always possible to do it even worse. You can use the D-pad to navigate a cursor around the page, and it becomes really tedious. There are alternatives. Analog controllers, if you have a game console, and it works a bit like the red eraser head in the middle of a IBM ThinkPad keyboard. Works pretty good. we have remotes with trackpads. We have remotes with air mouse. And it works a bit like a remote. You just point at the screen, and if you move your hand, the cursor will follow your movements. And if you use it for more than 5 minutes, your arm will fall off. But, okay. One other thing is second screens, and this is the gamepad from the Wii U, and you have actually a second screen right in front of you. And you can use it, it has a touch screen, you can use it to navigate to the site you want, and it also shows up on the television. And that makes me think, why would you even bother viewing it on the television anymore if you have a screen already in front of you? Yeah, perhaps to show something to other people, but okay. And many manufacturers also create apps. Again, why not browse on the phone itself if you already have it in your hand? But anyway, this is for the Xbox, we have an app for the PlayStation, and for WebOS, and there are many more. And how do we input text without a keyboard? Again, the D-pad. And it's letter by letter, and it's extremely irritating for long URLs, and please make your URLs as short as possible, because this is not a good way to navigate. There are luckily alternatives. We have remotes with keyboards, and people used to laugh at Google for their enormous full keyboard remotes for the Google TV, and they compared it with the simple and sleek and minimalistic D-pad, the Apple TV, but for text input this is actually far, far better. And we have wireless USB keyboards, and what most people don't know is you can actually plug them into your television or game console and they just work. And sometimes they even have built-in trackpad. And again, we have apps like the Xbox, the PlayStation. And we have gesture control. And I've tried this. I created a little movie. I tried to navigate my own site with gesture control, and I'm going to mimic what I did to create that movie. So, here goes. Now, it's nice, but it really doesn't work. And again, your arms will definitely fall off. So how can we control these input methods directly from JavaScript? We have mouse events, we have touch events, we have keyboard events. But how about D-pad events, gamepad events? Might be useful for HTML games, for example. The D-pad, well, maybe. The D-pad is actually just a keyboard. So we can use keyboard events. And this works okay. I'm not saying it works great, but it works okay, because we don't have any predefined keys, we don't have any predefined key codes. And these key codes, they vary between manufacturer and sometimes between models. So we know a key is pressed, but we don't know which key it was. It's a tiny thing, but it makes things difficult. And what we also must do is use prevent default to make sure the default behavior of the browser does not kick in. And that actually does not work on every device, but okay. How about the gamepad? Again, maybe. We actually have an API for that. It's called the gamepad API. And when I tried it, I was pleasantly surprised because it works on the Xbox One, and the PlayStation 4, and the Wii U, and the WebOS television, and Tizen. But then I took a closer look. And sometimes browsers make little mistakes, and sometimes they make big mistakes. They forget to hook up the rendering engine to the hardware. And so we have an API, get gamepads, and you call it. And what do you expect if you have gamepad connected to it? An array with the gamepad. No, the array is empty. So you can't use it. And actually, there is one browser that did work, and that was the Xbox One. All the others gave me an empty array, so I was pretty disappointed after all. Luckily, the Wii U has its own API, because why would you want to use the standard API? But this one actually works, so okay. How about accessing the webcam? Because game consoles usually have a Connect, Xbox Connect or PlayStation Eye, and sometimes smart TVs. They ship with a webcam, which you can use for Skype, for example. So can we use it from the browser? And the answer to that is no. But there's an asterisk. The Xbox One is getting an update to Windows 10, and it's probably going to be supported on that one. It's good. Yay, Microsoft. Gestures. Well, no. And I've been talking to some people at Microsoft, and perhaps they're going to support it, but let's just see and find out. So, the next difference. The difference between a television and a monitor. Overscan. And due to historical reasons, televisions will not show the borders of the complete image. And a browser built into the television actually is not affected. But any device connected to HDMI is. So if you connect a game console, we're going to have to deal with this. And what happens, the television enlarges all images from the HDMI input by 5%. And then the borders are chopped off. And we have a slightly smaller picture. And this may be a problem if your content reaches the borders of the screen. And there's another additional problem because overscan causes blurry output. We have lower quality, and that's actually pretty clearly visible on the screen. So how can we solve this problem? Well, there's a solution. It's called overscan correction. And what it does, it makes sure that the browser does not use the edges of the image. It creates a black border around it. And when the image is enlarged, the black borders will fall off, and the content is actually still fully visible. That works. But not every television enlarges the image by exactly 5%. That can vary between manufacturers and even between models. So how do you configure this? Well, this is on a PlayStation 4. We make sure the sides near the edge of the screen, and then we know exactly the enlargement that particular television uses. There is a complication, because if you have a PlayStation 4, it will always show the browser without overscan correction. Even that we just configured it, it will not use that. So, yeah, the edges will fall. Solution 2. No overscan. It is possible to disable overscan on many television sets, and it's called screen fit or pixel perfect or just scan, which by the way is translated in German as jetzt suchen, which doesn't have anything to do with overscan, but okay. And this actually works pretty good, because we also solve the problem of the low quality because of the enlargement of the screen. And there is one thing. Just imagine your parents. Do they know how to set this up? Yeah. So nobody is going to use this. And once again, we have a problem. And ironically, it's again on a PlayStation. The PlayStation 4 never used overscan correction. The PlayStation 3 always uses overscan correction. So even if we configured our television to show no overscan, we have these nice borders around our image. And we can't get rid of them. The viewport. I advise you to read PPK's blog about this and his book, the Mobile Web Handbook, because it has a very clear explanation about viewport. And I'm going to explain it in 3 slides. So I'm doomed already. But I'm going to try. The visual viewport. That's the part that determines what part of the screen is visible. And we have the layout viewport. And that one decides how the page is rendered. And if we change the width of the layout viewport, the rendering of our site changes, at least if you use responsive design. So, the default width on desktop is the width of the window. The default width on mobile is usually 980 pixels. There are some differences, but usually 980. And you can actually change them. We'll get to that. The default layout viewport on television screens, on smart TVs and consoles, are all over the place. They're something between 800 and 920 pixels. And as you just saw, the width changes the rendering. So all of these devices render differently. Like I said, we can change that. We have the meta viewport tag. And that works perfectly on mobile. Instead of the default 980 pixels, we can use it to set the width you want. And you can set it to the width of the device, for example. And again, we have a complication, because while it works on mobile, it doesn't work on smart TVs. It doesn't work on game consoles. So now we have all of our devices, and all websites look differently. And there's nothing we can do about it. An added complication, device pixel ratio is also not supported. So if we have a screen with a small viewport, we expect that every CSS pixel consists of multiple device pixels. So we want retina images, just like our iPhones and Android phones. We want 2x images or 3x images. But that doesn't work because device pixel ratio is not supported, so the retina images are never loaded. there's an exception. Panasonic televisions use Firefox OS and they do support it. So how do these differences all look? We have the Nintendo Wii, the Wii U, LG WebOS, and so on, and so on, and so on, and so on. Things get smaller and smaller. This is a list of all the devices I tested, and it's all over the place. Device pixels are not always device pixels. And sometimes they are not physical device pixels, they're virtual device pixels. For example, if you have a 4K television, they usually render on HD resolution because 4K is far too high for the slow processors and memory of the smart TV. So that actually makes sense, but again, it complicates things. Philips Android TVs from last year's series work on 720p, and they're upscaled to 1080p. We have the Wii U, which uses the resolution of the screen of the gamepad, and then upscales. And the PlayStation TV, for example, which is basically a PlayStation Vita, but without a screen. It uses the resolution of the PlayStation Vita screen. Yeah. Number 3, another difference. The distance to the screen. Because we view or because we sit further away from our television than from a monitor, we actually need to change the look of our site. And everybody who looked into it basically agrees we need to make text and images 2 to 3 times bigger than what you're used to. Otherwise, the text will simply be too small. Now, let's bring this all together. Responsive design will not work. We need something different, the opposite. We need fluid design. And we're back in 2004. We need the same layout on different viewports, and we can use, for example, percentages. If you have a small viewport, 50% of the viewport may be less pixels than 50% of a big viewport, but when it's projected on the screen, 50% is still 50%. So this will work. And we can base the font size also on the viewport. Just set it to a fraction of the width of the screen. Works. Perhaps we can even use viewport units. Well, maybe with a polyfill on modern devices, but okay. And we need to make sure we have proper margins, because we can't trust our parents to set up their televisions correctly. So, there's a good example, the YouTube TV website. And it actually works very good on all different kinds of smart TVs and consoles. And it actually works pretty good on just a laptop connected to the screen, to a beamer or a television. And like you can see, they changed the whole look of the site. They adapted it to televisions. How can we do this to our own sites, if we want to? How can we do this? We need to identify smart TVs so we can serve them with special CSS or... We have the CSS media type. Perfect. At media, TV. Fantastic. It doesn't work. Because all television browsers use the CSS media type screen. Just like phones use screen and not handheld, everybody uses screen. Perhaps we could look at the screen size. 920 by 1080, that's television, right? No, that also doesn't work. Because monitors and phones often also use HD resolution. And television browsers, like we saw, often use other resolutions. So we have a lot of false positives and a lot of false negatives. So it really doesn't work at all. Perhaps user agent sniffing? I know it's a dirty word, I know. But if it works, yeah, it doesn't work. TVs are not always recognizable. This is, for example, a user agent string of an LG Netcast television, which identifies itself as Safari from Korea on Linux. There is a solution. It's called couch mode. And we can create two different sites, just like it's 2004, and link to it from our own site. Or we could use a script to set a couple of cookies and load conditionally based on that. It's not really a good solution, but it's the best I can give you. And it actually works pretty okay. The Vimeo website uses it, and you can use it. There's a button always on the screen to enable couch mode, and it even works pretty good if you connect your laptop to the television screen. So it doesn't have to be a television browser. The fourth difference, and that's feature detection. And basically every feature that talks to the operating system or hardware is suspect. And that's what I said on my blog 2 months ago. And I've already alluded to that with the gamepad API. Sometimes manufacturers forget to connect their rendering engine to the hardware. And I have another example, geolocation. This is pretty simple code. It's just a call to get current position, and before we do that, we feature detect. So that's good. So we could provide an alternative. But we're not interested in that right now. There's this piece of code. There's a callback to success and a callback to failure. How many ways can this go wrong? Lots of ways. First of all, failure is called with a permission denied error. And that's actually not that bad, because we can handle that. We need to provide a failure callback anyway, because maybe the user doesn't give permission. So that works for me. But how about when no callback is called? Then your website is just waiting for something to happen, but nothing is happening. And nothing will ever happen. So we need to take that into account and create a timeout or something, and just cancel feature detection if we don't get a callback within, say, 5 or 10 seconds, I don't know. There are more. Success is called with the coordinates 0 and 0. And that means the user is somewhere in the Atlantic Ocean. Probably not right. And the last one. There's a fourth one, and it's almost comically wrong, because it's on a Google TV, and it shows the coordinates of the Google headquarters in Mountain View, California. So that's really useful. Probably not too far off, because how many Google TVs were sold? Probably all users of Google TV are living in Mountain View, California, so but it's still pretty big error. So, is there actually a future for web apps, browsers on big screen? we've seen lots of problems and not that many good solutions. And a couple of weeks ago, I received a new Apple TV from Apple. And it has a proper SDK, and it's based on iOS, and it has an app store. Will have an app store. So this is a pretty big opportunity for big screen browsers. And I have one, and I looked at it, but it does not come with Safari. Actually, it does not even have a web view. And the App Store doesn't allow you to create your own rendering engine. So there are no browsers on the Apple TV. And there will be no browsers on the Apple TV. And you can build apps using TVML, which is XML-based language, and it describes the UI and exposes DOM. And you can actually use JavaScript and XML HTTP request, so it does feel somewhat familiar, but it's not a browser. The Android TV actually does not ship with a browser either. It does have a web view, so that's good. You can install third-party browsers, and many television browsers that use Android TV actually ship a version of Opera. But still, the fact that it does not ship with a browser by default like Chrome is worrying to me. Okay, that was smart TVs. Now e-readers. The scores are not that good. That's to be expected, because they usually have no audio, they don't support video, so they don't support those features. And the scores are not that bad. Yeah, they're bad. But they work, the browsers. What are the differences? Infrared touchscreens. And we all know capacitive touchscreen and resistive touchscreens. How do these infrared touchscreens work? Well, we have a row of LEDs and a row of sensors surrounding the screen. And if you put your finger on the screen, the light rays between the LEDs and the sensors are blocked. And that is what the device detects, and it turns that into coordinates. And because the sensors and LEDs are physically quite large, the resolution is not that great. It's far smaller than the display. But they support mouse events. That's already one thing. But the Kindle and the Pocketbook are quite limited in how they support mouse events, because they only support mouse down and mouse up at the same time. So when you press your finger, nothing happens. You release your finger, it fires both the mouse down and mouse up event. The Kobo is better. It has actually separate up and down events, and it actually supports mouse move. So that's, you can actually do something with it. And the Sony is fantastic. It supports touch events. For one finger, okay, and the device is not for sale anymore because Sony left this e-reader business, so we don't have anything. Yeah. Doesn't help them. But if you have one, it really works quite good. How about e-ink screens? Well, how they work is quite complicated, but I'll try to explain it in a simplified way. We have a lot of microscopically small balls, which are, have pigments, and we have electrodes. And when you apply a charge through the electrodes, the balls will turn. And that way we can create pixels that are black or white. And there's one advantage, because if we lose the charge, the bolts will stay like they were. So it's very, you don't need much energy. You need to apply only a charge when you want to change it. But it's slow. It's really slow. It's really, really, really slow. And even that is not enough to let you know how slow it actually is. I created a little movie, and that should give a good impression. Yeah. So maybe those CSS animations and transitions weren't such a great idea after all. One additional problem is that we only have 16 shades of grey, and two completely different colors can look exactly the same in black and white. And it's something that isn't just specific to e-readers, because people who have problems with seeing certain colors will experience the same things. So that this is actually something we all should look at. How can we identify e-readers? Because we want to change the colors and we want to disable animations. How can we do that? There's a CSS media query for that. Monochrome. All our problems are solved. But it doesn't work. You probably expected that. All e-readers I tested act like they have a color screen. Because the translation to black and white happens in the screen controller, not in the browser. So the browser does not know it has an e-ink screen. We could do user agents. Yeah, I know, it's bad. And even then, we don't have a universal marker in the user agent string. We can only recognize individual manufacturers or models. So we need to keep that up. And every time a new e-reader is introduced, we need to update our sites, which everybody does, right? Last topic for today, portable consoles. And they're a bit more advanced than those. We have basically two families. We have the Nintendo DS and we have the Sony PlayStation. And we're not going to look at the PlayStation because it's too normal. It's not interesting at all. It's basically just a mobile phone. So. The Nintendo DS family, that one is pretty interesting because it has two screens. And well, actually, it's not that interesting at all because it's surprisingly normal. We have a dual visual viewport. And everything that's on the bottom screen, that gets shifted off when you scroll. When you scroll, it's shifted on the first screen. And that's all there is to it. Of course, you need to make sure you only interact with the bottom screen, because that one has a touch screen and the top screen doesn't. And I always use that little pen to click on the top screen, but it really doesn't work. And that's basically all there is. And I have a small movie, but it's not that exciting actually. And for one thing, for once that is a good thing. Normal browsers are actually very good to have. So, at the beginning of this talk, I asked, are there any weird browsers left? Well, I think the answer to that is definitely yes. There are. And I want to leave you with this very inspirational quote from Jason Grigsby. We cannot predict future behavior from a current experience that sucks. And I really hope he is right, because the current expectation really sucks. And he said it's about smart TVs, so yeah. But wait. Let's go back one step. We talked about grid browsers like they are something special. But actually they're just browsers. And when we create our sites, we don't know what our visitors are going to use. And some of our users may be visually impaired or use a screen reader. Some of them may use their mobile phone. And some of them may use an e-reader or a game console. And the web isn't a single platform. The fact there is a multitude of different browsers is inherent to the web. And that is what makes it great. The web is for everybody. And a lot of techniques that make the web more usable for these weird browsers are techniques you should already be using to make your sites and pages more accessible. And making pages accessible isn't just for people with handicaps, it's for all of your users. So this talk wasn't about weird browsers. Well, it was, but it was about assumptions that we as web developers make and expectations that we have. And that these assumptions and expectations may sometimes be wrong or too limited. And if there's one thing I want you to take away with you tonight, is that the web is more than just Chrome and Safari and Internet Explorer. Thank you.